Well, hey there, everybody. Let me get my headphones plugged in so I can hear myself think. Greetings, everyone, and welcome to today's Grower Talks webinar, Indoor versus Greenhouse Cannabis Growing. I'm Chris Beatties, editor of Grower Talks magazine and the e-newsletter Acres Online, and I'm going to be your host for the next hour or so as we tackle this very interesting topic. So, now, why is Grower Talks addressing a topic like cannabis? Well, it's because it's a horticultural crop, and our job, it's a horticultural crop like bedding plants, orchids, tomatoes, anything you grow in a greenhouse. And our job is to keep you informed of the developments of all those kinds of crops that might be potential money makers for you. It's your job to decide if that crop is for you or not. But there is a big difference between cannabis and other horticultural crops in that cannabis has sort of since its inception been grown indoors a lot, not in a greenhouse. And what we're going to address today is whether or not that's the best way to do it. We're going to compare indoor versus greenhouse growing. But to do that, we need an expert, as always. I'm never the expert, but we've got one. You can see him there on your screen. He is Nick Earls, the cannabis specialist for Wadsworth Control Systems. Welcome, Nick.
Thanks, Chris. Thanks for having me.
It's my pleasure. Now, where are you broadcasting from today, Nick?
I'm in Denver, Colorado.
Denver. Well, that is kind of the heart of cannabis production. You've actually got some experience in that crop before your time with Wadsworth, right?
Correct. Yeah, I did indoor cultivation here in Denver, and I also did greenhouse cultivation for cannabis here in Colorado.
All right. And your background is in not a controlled environment agriculture, right, from University of Arizona?
That's correct. And after I got the degree, I actually pursued a job in hydroponic greenhouse vegetable production, growing different varieties of tomatoes, bell peppers, and cucumbers, and then saw the big boom of cannabis in Colorado and decided to go for it.
All right, very cool. So in other words, you know your stuff. I'm using an old system, my old system here of putting the picture of the presenter. There's a lovely shot of Nick. But we can see you live. And same with me here. I'm broadcasting live from the Ball Publishing Broadcast Studios, where we're using this new system called Workcast, which allows you to actually see us as we do our presenting here. And I hope it eliminates some of those glitches we used to have in the old Ball Publishing webinars. But just in case, there is live tech support on hand. As far as I know, if the Workcast folks are out there, you can just click on the support button or help button to get help. Now, we've got a couple of little housekeeping things. First off, thanks to this week's sponsors, the National Greenhouse Manufacturers Association, whom I've never done a webinar with. This is our first. Wadsworth Control Systems, who so generously provided Nick there. And then, well, of course, me. I do it all the time here. If you have questions, on the right-hand side of your screen, there's an arrow and something you can open up an ask a question area. Go ahead and ask a question, and we'll get to them either as we go along or we'll save them for the end. And I'll even give you Nick's contact information if it's more complicated than we can handle here in this venue. And lastly, if something comes up to where you have to leave the webinar, or you want to watch it again or share it with colleagues, friends, or whoever, it will be archived at the same place where you signed up, growertalks.com/webinar. So that said, Nick, I'm going to segue into your slides. Ready to go?
I'm ready to go. Thanks, Chris.
All right. Take it away.
All right. So welcome, everyone. Thanks for joining us, and thanks again to our sponsors. I'm going to be talking about indoor versus greenhouse cannabis cultivation. And some of the things I'll be jumping into is going to be talking about climate similarities, differences, indoor grow equipment versus greenhouse grow equipment. I'll be talking about light depth systems, shade curtain / heat retention systems, single source lighting, which is used in indoor grows, as well as greenhouse supplemental lighting. And then also kind of compare the two and talk about utility consumption with indoor and utility consumption with greenhouses. And what's a better move, especially with the price of cannabis slowly dropping. And we've seen that a lot here in Colorado. So first I want to talk about is flow and design. Everyone kind of says, oh, well, the first thing I'm going to do is, design the building. Well, number one thing that I highly recommend, and I see this done improperly a lot of times, is you want to have your head grower or growers involved in that design process. So some say, well, I don't have plants yet, Nick, and I just need to get everything kind of figured out. Well, I recommend having them in there for the fact that you're not going to have as much rework. If you have your head grower involved, you're going to be able to design that facility for his needs and how he wants to grow. And in the meantime, while there's not plants, he can start working on those standard operating procedures, which again is going to help benefit you in the way of figuring out how to design this facility. So standard operating procedures are going to do everything from when I take a cutting, where does that cutting go? What's the next step? How long does it take? Is it going into a 1 gallon pot? Is it going into a 3 gallon pot? And then how does it transition into the flower stage? Where is the flower rooms? What areas do you have to walk from to get into that area? Because all we're trying to do is eliminate cross-contamination. So you need to have all these things kind of in your mind. Another thing you need to think about is how are you getting equipment into the facility? When you bring in soil or cocoa or some type of grow media, you need to make sure that you have some type of loading dock and some way to get it into that area. I've had growers where they've brought in pallets of soil, but didn't realize that they needed to have a bigger door to be able to get that pallet through. So certain little things need to be considered. Another thing that you need to consider is a total grow control system. And this is for if you're in a greenhouse or if you're in an indoor grow. A lot of times I see indoor grows with multiple thermostats for all their air conditioners, also with irrigation controls, with CO2 controls, with lighting controllers. And really, you need to have one system to do it all. All these things need to work together. They need to really come together. So if you have CO2, and that's being supplemented based on a parts per million number, but you have an exhaust fan that's kicking on because it's too hot in the room, you're now exhausting out all of that CO2 and wasting it. So you need to have these things work together. If you're implementing CO2, you need to have that fan off. So it's something I highly recommend you need to look into. Another thing you need to consider is you need to have water purification, so a water test done so you can figure out how big of a filtration system you need. And then how are you going to deliver that purified water to the plants with nutrients? Are you using dosatrons? Are you using a fertigation unit? And how do those lines run over to those rooms? How much water can you produce a day? And how many pots do you need to fill with water? So these are all things that you need to really consider. Another thing that I don't see very often when it comes to grows, whether it be an indoor grow or a greenhouse grow, is a quarantine room / genetic room. What I mean by that is you should have a room that's close to an exit or a doorway that if you want to bring in new strains into your facility, which everyone does, you need to have that available so that you can bring that strain in. You can keep that strain in that quarantine room for X amount of time to make sure that there's no pest, disease, mildews, molds, anything on that plant. So that when you do transition that plant into your actual main grow area, that you're not cross-contaminating and jeopardizing your crop. So things to consider. Another thing you need to consider is your pesticide laws in your area, as well as application certification. So maybe you need eye wash stations in X amount of areas. So there's all these little things that kind of come into play that you need to consider. And most of them, you need to have a head grower there with you. So next we'll talk about the first stage of growing, and we'll kind of relate it to more of a warehouse design. First, I'm going to talk about vegetative stage. So vegetative stage is usually you're starting with a little seed or you're starting with a cutting. And once that cutting starts to grow, it'll get put into a bigger pot in that same vegetative stage. The cloning operation is typically done in a propagation flat with plugs and a humidity dome, or you'll see a lot of times cloning machines. And both methods work very, very well. One thing to consider if you're using a cloning machine, always make sure to clean it heavily after every single use. A lot of customers and a lot of growers I've talked to have kind of switched away from those machines just for the fact that they didn't clean it well enough and didn't have the same outcome as before. When you're in a vegetative state, and you're not in cloning, you're going to be usually seeing metal halide lights or ceramic metal halide lights, and sometimes LEDs. And these are the most common. I've also seen double-ended HPS, but for metal halides, ceramic metal halides, and LEDs, you're going to have more of a blue spectrum most of the time, which is actually going to provide you with a shorter node spacing, and that's going to be a benefit to once you get to that flowering state. Another thing to consider in a warehouse application is doing tiered racking, so you have multiple levels of plants growing, or doing rolling benches. Tier racking is tending to be the more popular method for the fact that you want to really maximize your square footage, and you can actually grow a little bit shorter plants and have more harvest per day. But if you're on a plant count scenario, then you're going to want to grow larger plants and make sure that you have a proper square footage and design for that. Mother rooms and veg rooms typically are about 25 or 75 to 85 degrees. Some of you might say that 85 degrees is a little high, and I'd agree with you. But if you're using LEDs, there's no radiant heat, almost no radiant heat coming off of those fixtures, so you can actually put your room at a higher temperature, which is going to benefit you from not having to use as much HVAC. And we'll see the numbers in a little bit of what comes down to percentage of most utility usage in an indoor grow. Also, when you're in a vegetative stage, clones are usually in a 24-hour light cycle, and your little bit bigger plants in the vegetative stage are usually going to be an 18-6 light cycle. And what I mean by that is 18 hours of light and 6 hours of darkness. I've also seen people do 24 hours of light, and there's no problem with that. But you're going to save on utilities if you go with an 18-6 pattern, just for the reason that, just like humans, plants need to have a little bit of a sleep time. So once they absorb enough light energy into that plant, you can actually go ahead and it's going to go to sleep. So you might as well kick those lights off for 6 hours and save that power. Next, we'll talk about the flowering stage. So after you transition and you grow your plant to however tall you like and top it as many times to make sure it's nice and bushy, you're going to be pushing it into your flower room or transitioning it into a flower stage. Flowering stages usually use 1,000-watt HPS lights or double-ended HPS lights, as well as LEDs. More growers are also starting to experiment with using ceramic metal halides in the flowering stage and getting pretty good results. The difference when it comes to lighting in a veg stage with flower, besides just the fixture, is you're going to be doing a 12-12 light cycle. What that means is 12 hours on, 12 hours off. We're trying to trick that plant into a flowering state. And by doing this, that's where we get all that phenomenal bud and product. In a flowering room, usually about 75 to 80 degrees, and again, that can be a little bit higher, but it's really just going to, and the higherness is usually going to be for if you're using those LEDs. When it comes to humidity, you really want to keep that humidity below 50%. Typically, people are taking a reading off a centralized sensor. If you're reading that sensor and it's saying 50% for relative humidity, that means in that canopy area, you have little microclimates under each one of those leaves. And it's going to be a higher humidity in that area. And that is a perfect breeding ground for mildews and molds, as well as pests. So you want to consider that. You need to be able to keep your humidity down. And we'll talk about different ways to dehumidify, whether you're in a greenhouse or an indoor grow. When it comes to light levels, in a vegetative stage, we're usually looking at 150 to 400 micromoles, depending on that plant's size and height. If you're in a flowering stage, we're usually looking 800 to 1200 micromoles at that canopy height. But one thing people need to consider is when you're going from a vegetative to a flowering state, you need to make sure that you're slowly increasing that micromole value as that plant transitions. You don't want to shock the plant by going from 400 micromoles of a certain wavelength to 800 to 1200 micromoles of a little bit different wavelength. So keep that in mind. Isolated HVAC systems are something I highly recommend if you're an indoor facility. Reason being is I've seen people do large RTU units on the roof of their facility and share that unit between two grow rooms. Well, if you have any type of mildew or mold, and powdery mildew being the #1 issue in the cannabis industry, you don't want to be pulling spores up through that return into the air conditioner and distribute it into the other room next door. So make sure you have an isolated HVAC system that's taking care of each individual room, or multiple HVAC systems taking care of their individual areas. CO2 enrichment is something that is very necessary for the cannabis crop. So people have been using CO2 levels of about 1,000 to 1,200 parts per million. And again, this is where you don't want to be evacuating that air out and having a total grow control system to take care of it. You also want to have your CO2 being distributed above the plants for the fact that CO2 is heavier than air and will fall down into your canopy. Average room size for indoor grows is usually about 1,500 to 2,500 parts per million, or 2,500 square feet. And that, I've seen bigger, I've seen smaller, but that's kind of a nice average size. I also like that size for that you can have your plants at the same stage of growth per room, fully harvest the room, fully clean the room, and then repopulate. So you're not having any issues with, again, cross-contamination. If you have spider mites in one area over here, you don't want to bring more plants, new plants in a spot over here, just because they're going to be moving over. One thing to also consider is CO2. Wherever you're at, you want to check to see what your CO2 code is in that area. Some states require that you have a visual and audible alarm connected to an exhaust fan inside your room and outside your room. So make sure to check with your county codes on that. Next, we're going to talk about how do you control all this, whether you're indoor or you're in a greenhouse. And that's going to relate
before
to
you go any further, I had a quick question.
Yeah, go for it.
On the average room size, does that in any way equate to bay size or zone size in a greenhouse? Or are you going to get into that?
Oh, great. That's a great point, and we can talk about that a little bit right now. It's the same aspect. So great point, Chris. If you have a very large bay, you do have that issue of if you have some type of pest or disease in this corner over here, you obviously want proper air circulation, meaning mixing that air evenly, which is also a nice way of mixing those spores evenly through that zone. So you do want to have a little bit smaller greenhouse. You don't want to go full blown. It's better to have multiple small greenhouses instead of one large greenhouse.
Okay, thanks.
And to control those areas, you can control them differently. So you can really control them in ways where, if each zone is individually different, you can actually space out your power usage by how you want to divide those zones and when certain pieces of equipment are turning on. So with a total grow control system, is what I call a proper environmental control, it can control all of your equipment with its own individual set points. So the benefits there are, instead of turning on 4 air conditioning units or 4 exhaust fans, depending if you're indoor or greenhouse, you can turn them on in slow stages. So now you're saving on that utility consumption, but you're also making a proper environment for your plants. So instead of saying, hey, we're going from this degree air and now shocking it with this degree air because we turned all 4 exhaust fans on, you can have that as a slow, gradual transition, not shocking your plants. Using a control system, you're also going to be able to look at your data and be able to adjust your equipment. So maybe you say, hey, now we can actually base it a little bit earlier in the day because we have a little bit more sunlight, and let's transition that so that we're not using as much supplemental lighting. So lots of different ways to increase your yield, but also save on utility costs. So as we transition into talking about greenhouses next, I think there's some points that people need to learn. When you go from an indoor grow and then you're now going to be doing greenhouse production, there's a lot of changes that come into play. So instead of going from single source lighting, so lights turning on in an indoor grow and turning off, you're actually going from supplemental lighting in a greenhouse and turning it on and off based on the light value you're reading at the canopy height. So now you're only applying light whenever you need it. Same comes to when you're using exhaust fans in a greenhouse. You're going to turn on a few exhaust fans at a time instead of using a thermostat. This is going to save you on power and, again, not shock your plants by dropping a different air temperature in the canopy area. So as we transition into greenhouses, there's a few different types of equipment. One most popular, and this is used over many types of different grows, is going to be a shade system. We call it a shade heat retention system. What we mean by that is if your greenhouse gets too hot or has too high of a light value, depending on your crop size, you're going to want to cover that curtain. By covering that curtain, you're allowing to cool down that greenhouse, and you're also providing a buffer. And that is also a great point for when you're at night. So at night, we consider that a heat blanket, and that's where we talk about that heat retention. Is that heat blanket is actually going to provide that heat down low where you need it at the canopy height. So we know heat rises. If you have a blanket to keep it down, now you're going to be saving on your utility cost and providing the plants with what they need. Something I definitely recommend you take a look at. But for cannabis, we also need something to control our light, the amount of light that we're having come in the greenhouse and when it's coming in the greenhouse. So this is when we need a light depth system, what we also call a blackout system. So if you're in an indoor grow, you just have all your doors shut and your lights are on or they're off. In a greenhouse, we need to control when the lights are on and off and what we call a photo period. So with these blackout systems, here's a couple being displayed in the pictures here, you can actually have a full ground-to-ground system, which you can see over here, starts at the ground, goes up, overhead, and back down. And we've also seen people put actually solid metal insulated sidewalls, and that's also a great idea. Really just depends on what your area is like. If you're in Arizona or some type of hot desert, it might be more beneficial for you to go with a setup where you have a full ground-to-ground system so you can get maximum light penetration. But if you're somewhere on the East Coast where it could be really, really cold, it's going to be more of a benefit for you to have metal solid sidewalls with a clear roof, because now you can get more plants in there. You'll have to supplement a little bit more, but not much, because you can still utilize that overhead sun.
And Nick, we might make the point that for those who aren't from the greenhouse world, these systems have been used for generations to bloom photoperiodic crops like poinsettias and chrysanthemums and things like that. So it's certainly nothing new just because of the cannabis world.
Correct. Actually, Wadsworth, one of our first curtain systems was a blackout system. And, this was many, many years ago, 40 plus years ago, before the cannabis industry had really taken off. So yes, it's a very good point. And you can actually have dual systems too. So you can have a shade system and a blackout system, and now you can utilize both. So now let's talk about cooling. We talked about indoor cooling and using air conditioners. Well, there's a lot of options when it comes to greenhouses. So lots of different types of vents, from rolling up side vents to roof vents, ridge vents, and also full roofs that actually open the entire roof up to the air. So you definitely want to talk to your greenhouse manufacturer. They are going to know all these different types of cooling, but the most common type of cooling for a greenhouse is going to be called what we call a fan and pad system. In the picture here, I have the pad being displayed. It's basically a corrugated cardboard that is coated in a certain enamel that you pull air through, and at certain points you can actually turn on a pump water through it, and pull your air through, which would also go through the canopy. This is going to cool down your crop in a very efficient way, in a very even way. And I'll show you a picture in a second that'll describe it a little bit more. But other options of cooling, you can actually use evap coolers. Usually you have to have quite a few of them, and it's going to be more beneficial for you to go with a fan and pad system. You can also use air conditioners, and chiller systems are getting really popular. Chiller systems are a great idea. They can be a pretty expensive upfront cost, and actually the equipment alone takes up a good amount of square footage. So it really just depends on what you're looking for and if the chiller system is good for you. Climate batteries are another option. I haven't seen too many of them for cannabis production, but it's basically having tubes beneath your greenhouse with a fan, and that fan is set to pull air up to cool at certain times of the year, or also pull air up to heat certain times of the year by using tubing underneath your greenhouse.
Nick, we've got a few questions that have
Oh,
come in that
yeah.
are some of them are kind of on this topic. Let's tackle a few of them while we're here. And I'll try to get to all of them. David wants to know, don't pests enter the greenhouse when you've got ventilation running?
Oh, phenomenal question. So, David, usually you're going to have insect screening, and I can actually show you that in the next image. So, there's certain insect screening that actually has a certain micron size, so it'll be a hole size in the screen, so that pests can't get into the greenhouse. So, when you're pulling air through that pad system, on the other side there's usually a vent or louvers, and right on the other side of that you should have a bug screen wall. So, when you're pulling air through, those bugs can't make it through that screen. Same for roof vents. I highly recommend if you are using roof vents to make sure that you have screening on your roof vents. So yes, you don't get pests inside your greenhouse. Is that screening going to take care of it all the time? No, but it's going to help a lot. There's still going to be employees opening up doors and things being able to get in. You do have a controlled environment, which is a perfect environment for pests as well as plants.
There are also positive pressure greenhouse designs that actually run air through a screen, then into the greenhouse and creating a pressure that then kind of keeps things from being sucked into the greenhouse. It works actually the opposite direction too. So
yeah, correct. And there's, if you have a proper control system, a lot of times you can control those type of aspects by using pressure switch sensors. So if you always want a positive pressure, like if you're doing males and male genetics, you'd want a negative pressure. You can have those different options available.
all right, let's see.
Yep.
Go ahead. Let's see. Philippe wants to know, how do you manage humidity levels with a fan and pad system? Because that does automatically increase the humidity. That's how it works.
That is correct. And that is a fantastic transition into our next couple slides.
All right. We'll get to the rest of those questions as we go along. Don't worry. Hang on, everybody.
So just want to first show you this picture. This is a fantastic picture. This is a Nexus Vale greenhouse. They do a lot of phenomenal cannabis greenhouses. And as you can see, they have roof intakes in that corridor with bug screen, to answer David's question. And we'll pull the air in through there into the corridor, pull it across through the pad system, across the canopy, and out through the exhaust fans. And to determine how this works and how effective it can be for cooling, you would actually use a psychometric chart. A psychometric chart is used for greenhouse engineering and is a great tool for you to utilize. And I'll go over how to use one in a second. But pad systems are about 80% efficient. So that's really, really good. So if you're trying to cool down a greenhouse, for example, if it's 100 degrees and it's 80% efficient, we would actually, and it's 70-degree dry bulb temperature, we would actually end up with 76-degree air leaving that pad wall. You're probably saying, Nick, I'm looking at the 100 minus 70, and that doesn't equal 76. And you're correct. And I'll show you how I got those numbers. And we'll do an example of doing dehumidification, just like Philippe's question. So here's a perfect example. So for dehumidifying in a greenhouse, you're going to be venting and heating. So hot air can hold more moisture, meaning that it will reduce the amount of relative humidity. So if we look at this chart, this is a psychometric chart. That very bottom x-axis is going to be your dry bulb temperature. The very top curved axis is going to be your wet bulb temperature. And these curved lines in between are actually going to be your relative humidity. So for an example, and I have a couple of them, for an example, let's start with 60-degree air and 70% relative humidity. So if we heat that air, again, allowing more capacity to hold water, if we heat it up to 75 degrees from 60 degrees, that's only 15 degrees, we will drop the humidity from 70% to 42%. So this is how you do it, is you make sure you're venting and heating your greenhouse to dehumidify. And you might say, Nick, 70% humidity is pretty good. I'm in a very humid area. So let's look at another example. Another example would be if the outdoor air starts at 60 degrees, just like before, but we're at 90% humidity, 90%. How can I drop that air? Well, again, let's just raise the temperature in the greenhouse 15 degrees to 75 degrees. relative humidity is going to drop to 53%. 53%. So you ask how to dehumidify in a greenhouse. It's going to be venting and heating. And to do that, you have to have a proper control system to do this. Chris, are any more questions coming up about this?
Not specifically on that topic. So keep on going and we'll tackle these near the end.
Sounds good. So if that doesn't work and you can't keep venting and heating because of certain location, or maybe it's just happens to you maybe 1 month out of the year, you're going to need to consider supplemental dehumidification. Especially if you're an indoor grow, you're going to be almost required to have supplemental dehumidification. So I have a few different options here. That top left-hand corner is going to be a Climadry 705 dehumidifier. It's in an indoor grow in this current picture and has been utilized in many indoor grows. It does 705 pints per day, and it also has a 5-ton condenser, meaning it's going to help with cooling. Another unit right below that is going to be a Quest unit. They have a lot of different models. And both of those units could be in a greenhouse, they could be in an indoor grow, they could be in your drying and curing room. But all of them can be hooked up to an environmental control system. If you're looking for a large commercial greenhouse dehumidifier, because you need it, you pack in lots of plants and you're in a very high humid area, and venting and heating just isn't going to cut it for you, it only can do so much, then you're going to need to look at a larger system like in the top right-hand corner here. This is a dry G air unit, and they're getting extremely popular in many facilities, whether it be cannabis facilities or vegetable production. But the other thing you need to consider is air circulation. You need to relieve microclimates. If you have so many plants packed into one area, you're going to have leaves overlapping, and you're going to have development of microclimates. Those microclimates is a perfect breeding ground for pest and disease. So to relieve those microclimates, if you have proper air movement and proper pruning techniques, you should have a good reaction after doing that. And if you don't, you're going to have the transition of possibly having mildew and mold, but you have to have an IPM process put in play. So IPM is integrated pest management. And, it's management. I hear a lot of people saying, I need to kill all these pests or I need to get rid of this mold. It's management. Eradication would be great, but management is what you need to be considering. And this pyramid right here on the bottom is the perfect way of looking at it. You start with cultural control. This is something you should be doing all the time, as well as mechanical. But cultural control is going to be sanitation, plant spacing, rotations. This could be foot baths. So if you have a foot bath in front of each one of your zones, whether it be a grow room or a greenhouse, you want to step into that foot bath that has a soapy or bleach water and then enter your greenhouse. Same for exiting. So you're not having any sort of pest or spore that you're bringing into the greenhouse. The next step would be mechanical. So pruning techniques, making sure you don't have such a big bush and allowing for more air movement. Putting up sticky traps and looking at those sticky traps to see if you notice any type of pest. And then also dehumidifiers if it's needed. The next step would be biological control. So beneficial predators. And in my personal opinion, you should have beneficial predators being released even if you don't have an issue, for the fact that you want to build up populations of beneficial predators in your zone so that if something does come out, you do have things to help take care of that. Some of my favorites, like if you have 2 spotted spider mites, I'd say second most common pest besides powdery mildew when it comes to cannabis growing. There's a lot of predator mites out there that will help take care of that. From personal experience, I've used Andersoni and Persimolis. Both of them work really well together. One's a hunter. He'll go from leaf to leaf, from trellis to trellis. And the other one's a gatherer. He'll slowly corral all of these 2 spotted spider mites on a leaf and slowly pick them off. So these two work really well together. And there's a lot of other types of beneficial predators out there that you can use. But if that doesn't work, then you're going to have to go with a chemical pesticide application. I definitely recommend that you look at your state codes or county codes for what pesticides you're allowed to apply and what type of certification you have to apply that pesticide. For Colorado, you have to have a private pesticide applicator's license, and you have to follow quite a few different rules. So make sure to check with your county code on that. Another thing to consider when applying a pesticide, and this is from personal experience, was if you're in an indoor facility, you usually have multiple rooms all divided up. And then sometimes you might have other areas for processing or for drying, and there might be people working in those areas. So you need to consider whatever your county code is and how your facility is designed. You might only be able to do sprays or applications when no one else is in the facility. Sometimes if you're sharing a large warehouse with another company, that other company might not be able to have employees in the zone, meaning you might have to do a spray at a really late time just to make sure that you're keeping those employees safe. So make sure to look in your county codes to see what is the proper application for you. For greenhouses, you're usually spraying at night. So once that blackout cover closes, then you're going to go in and make an application because you don't want to be doing this in the sunlight and having sunlight rays going through this pesticide that is on your plant. It can actually burn the plant. And then you also want to consider where are those exhaust fans exhausting. Typically in an application stage, they're off and then you turn them back on. But you don't want to be turning on fans and it blowing on to where your parking lot is for your employees and they're leaving for the day. So just take in some of these considerations when applying a pesticide, and only if you have to. So let's take a look at some numbers. Now that we've talked about greenhouses and we've also talked about indoor grows, I have some information here. This is actually provided to me by the Cannabis Conservancy Group. They did a lot of studies and still are doing studies on cannabis, whether it be indoor production, greenhouse production, outdoor production. And here's some of the numbers. So if you're in an indoor facility, I mean, a lot of your percentage, over half your percentage is going to be used for HVAC and cooling. Because these air conditioning units use a lot of power. And then when you turn your lights on, your air conditioning is using even more power. So now the top two pieces of equipment in an indoor grow are going to be that are drawing the most power is lighting and HVAC units. So, and you can see some of these numbers here for Oregon averages and Colorado averages. I also have some of these numbers broken up for you. So if you want to look at kilowatt hours per square foot per year, here are some of the averages for indoor grows. Also for kilowatt hours per plant, kilowatt hours per pound, and then watts per square foot of lighting. Some numbers just to take a look at. If you are in an indoor grow, I recommend doing energy audits. There's a lot of companies out there that will do it, but it's something you need to consider just because of the amount of power you're using in an indoor grow. And you need to be able to tweak your environmental control system so that you're saving on energy usage. And there's a lot of companies that will help with this. But when we take a look at lighting, being one of the most, the highest percentage, that and HVAC, when it comes to an indoor grow, here's some perfect charts that show the examples. So indoor grow, you have your lights turn on, they stay on, and then they turn off. Single source lighting, just drawing power the entire time. If you're in a greenhouse, you might have supplemental lighting in the morning, and then the sun comes out, so you have no lighting. You're using the sun and that full spectrum of light. And then towards the evening, you might supplement a little bit at the end, unless it's a cloudy day. So from this study, again, provided by the Cannabis Conservancy Group, greenhouses use 4.5 less energy when it comes to lighting. And that's a big number when these lights are drawing anywhere from 3 to 6 amps per fixture. Another thing you can do to look at this is consider DLI. DLI is daily light interval. So what this means is on a perfect day, being that blue line, no clouds at all, we have perfect amount of sunlight coming in. We're supplementing those orange lines in the beginning of the day and at the end of the day. But if it's a really bright area and we're hitting a certain number, we're looking for amount of moles per day. If for cannabis, it's typically about 35 to 40 moles per day. So if we get close to that end of the day and we've hit 35 moles, let's not supplement for the rest of that day. That plant has taken in as much light as it can. So what can you do if you're in an indoor grow, or what can you do to help with utility savings if you're in a greenhouse? There's quite a few different options. One, I definitely recommend a commercial environmental control system, but there's certain equipment that can benefit you. So I have a couple pictures of LED lights here. I highly recommend LEDs if you're in an indoor facility for the fact of the amount of heat that comes off a double-ended fixture in an indoor facility is going to make your HVAC system keep running. And as we looked at those numbers aren't great. So with LED lighting, you're using less amp draw. You're also able to have the room at a higher temperature, and that's going to help save on that HVAC savings. With LEDs, you can also have these in greenhouses. And basically, if you have a controlled environment or controller, you can use it to benefit your environment by saying, I'll put a light sensor down at my canopy height, and I always want X amount of micromoles. So if you want 1,000 micromoles at your canopy, you can use these LEDs to say, I want them to get brighter, or I want it to get dimmer based on what the sunlight is, or based on what the crop height is. So something to consider, and that'll have less amp draw. Another thing to consider is variable speed air circulation fans and exhaust fans. So I see a lot of facilities with tons and tons of air circulation fans. They don't want microclimates and they don't want mildew and mold. Makes sense. But the big issue is if you have so many of those fans going on, the air is moving across the leaf so fast that it's drying your leaf out. So you actually get windburn. So if you have a variable speed fan connected to a control system, you're actually able to set points and say, hey, let's have a nice slow speed going on. And if set points get out of whack, saying high temp or low temp or high humidity, you can actually increase the speed of that fan when necessary. So just as displayed in the corner here, this DRAM half fan. Other options are multiple output equipment. So if you're using an air conditioner or if you're using a greenhouse, a lot of times you could have 1-speed or 2-speed exhaust fans or blowers and set those to separate set points. So now instead of drawing 10 amps at high speed, you could maybe be drawing 5 amps at a lower speed and be saving on that utility cost. Other thing to consider is lighting banks. And what I mean by lighting banks is the ability to be able to have 2 triggers at least to be able to turn lights on. So if you're in an indoor or a greenhouse, I recommend having a checkerboard pattern of lights so that you can have half your lights turn on and then the other half lights turn on if necessary. So if you're in a greenhouse, you're only supplementing when it gets cloudy outside. So if it's getting a little cloudy outside, you could turn your first bank of lights on. Now you're bringing it back up to the micromole level that you're looking for, but at the same time, you're not having any shock to your plants. If you're going from 400 micromoles to 1,000 micromoles, that's a pretty big shock for your plants, and you're going to be turning on a lot more cooling equipment. So if you have 2 banks of lights, you can turn on the first bank. If it gets even cloudier, turn on the second bank if you need so. So it's something to fully consider when designing a facility, is making sure you have that layout. You can also do the same thing with heating. Make sure you have different types of heat. Maybe you have floor heat. Maybe you have bench heat. Maybe you have unit heaters. Maybe you have a combo of those. I recommend having a combination for the fact that if one source of heat goes out, you have a second source of heat available. So once you have all this equipment installed and everything is figured out, now you need to start re-looking at your standard operating procedures, and you also need to be looking at your data. Data analysis is key. This is still an upcoming new industry, in my opinion, and you need to look at your data. So this is a perfect example transitioning from 2 banks of lights. So we can see here on this graph that they have 2 banks of lights. But you can see that both banks of lights turned on at the same time and basically went off at the same time. So they're not utilizing the aspect of being able to have different micromole values for your 2 different banks of lights. This is, again, going to save you on energy, not just light energy, but also from cooling energy. Another thing to kind of consider is you want to be able to have this data forever. Every time we're tweaking things, you're changing stuff, and you might keep changing things, and then things aren't the way, aren't going well like they were before. So you need to be able to look back at your data and say, how did we have things set before? Maybe we need to start fresh over again because we don't know what things we changed have thrown the plants into this devastated state. So keeping that data and having long-term data storage is important. The other thing that you want to be able to graph is sensors, set points, and equipment. So keep all of that in mind. Data analysis is key. A lot of people will set something up and leave it, and there's always a little bit of room for changing things. So keep that in mind.
And that applies to pretty much anything you're growing, not just cannabis.
Correct. And there's a lot of technology out there, so you got to make sure that you're utilizing that. Soil moisture sensors are getting really popular, so you can determine if you're overwatering or underwatering. And traditionally, if you're underwatering because that plant will tell you. But it's something to consider.
All right. Well, we've come to the question area, and we've got plenty of time left. So let's start at the. Let me start up at the top here. The first question that came in, Francois is asking. This was from one of your earlier slides when you were talking about light intensity levels, CO2 levels. Says that they appear quite high from a plant physiology requirement standpoint. Has there been any scientific experimentation done on this? Control versus treatment to verify that?
Yeah, so you're probably saying the light levels are high, and it's always crop specific. So great question. I mean, if you're growing lettuce, you're going to have a lot lower micromole level that you need to meet. But when you're designing these facilities, talk to your lighting manufacturer. They will design full light layouts. They'll explain what is usually best for your crop. Then you can also talk about what light levels you're looking for and make sure that light spacing, whether it be indoor or greenhouse, is done properly. And then
the recommendations you gave, those have come from like hardcore university research, or is this more anecdotal? What people have done in the past that seems to work? Where's your data come from?
A lot of testing, but also a lot of it is coming from other growers and other grow facilities to be able to come up with those micromole levels. But there's not tons of research yet. We are starting to get into that research stage from universities. There are certain universities that are starting to do hemp testing as kind of a, step into this industry. But there isn't tons of research yet. But, typically when you talk to your lighting manufacturer, they've been in tons of facilities and they know what those micromole levels are. They know what that spacing is for certain heights. And they'll be able to give you the right numbers. But these numbers I have are from studies and from seeing them actually produce.
Yeah, that is one of the challenges with cannabis is that universities have not been able to do the hardcore research on the crop yet. But I'm sure that's going to be coming, and we're going to be getting a lot more information. Let's see. Is it possible, back when you were talking about light, is it possible to have diffused light production in an indoor grow to basically getting more light down into the canopy to increase photosynthesis? Aluminum foil on the walls, that's what I've seen. Is that?
Great question. And actually, white, and I know you're talking about Mylar, Chris, and actually white is typically the better way of going about it because of the reflectivity. So making sure that you paint your floors white so you have that reflectivity going back up into the canopy. I have started to see growers using LED light bars that are actually putting them down into that lower canopy area so that they can actually get those light levels down, penetrating into the canopy. But another consideration for if you're having issues getting those light levels down lower is thinning out your canopy and removing some of those leaves.
Right. Yeah, and there's the interlighting that comes from the cut rows and the vegetable world as well. I know they do that.
Correct. I've seen it a lot for tomatoes.
Let's see. I'm not quite sure what that question. Do you advise for open or closed shading screen structure? I don't quite know
I think
Philippe,
you
send
might
that one
be
back in,
okay.
and
I think you might be
get back.
referring to having a screened roof versus having a solid polycarbonate roof. And that really depends on where you're located. Certain areas are going to benefit from that, but certain areas you're not going to be able to grow year round because of the fact of, if it's snowing, or being able to control that environment because you have basically an open roof with insect netting. So it really is dependent on location.
All right. Jim is curious about blackout. Comparing poinsettias to cannabis, is cannabis more sensitive to light leakage than, say, a poinsettia crop? I mean, how tight does your black cloth system have to be on cannabis?
That's a great question. It's actually kind of a debate in the industry for the fact that some people are using 2-layer blackout fabric and some are using 3-layer blackout fabric. And the 3-layer is going to have almost no light coming through compared to the two-layer might have a little bit more of a what we call a starry effect. And this is a big debate for the fact that there's a lot of outdoor growers that are having phenomenal results. And there's the star and the moon out there. So it really just depends on how big of a light leak it is, since light leaks can trigger hermaphroditic properties, and nobody wants that because that would trigger you to possibly have pollen, and then that hermaphroditic pollen would actually be pollinating some of your female plants, which would result in seed, which would also result in a poor product. So I always recommend you have it as sealed as you possibly can. If you can prevent light leaks in any way, why wouldn't you?
And I've never heard about hermaphroditic problems with poinsettias. So
I haven't either. I haven't smoked poinsettias either, though.
Timmy wants to know, talking about fan and pad cooling, how do you manage the temperature? Because it seems the closer you are to the pads, the cooler the temperature. When you get down to the fan end, it's going to be higher, which is absolutely true. There is that temperature gradient.
Yeah, no, very, very true. And what I've seen sometimes is putting that sensor, that centralized sensor, or having a couple sensors that take an average, but putting it in a location that's going to benefit you for your cooling, because you're 100% correct. It is cooler when you're closer to the pad side compared to the exhaust fan side, and you're going to need to base your set points upon that.
Mm-hmm. I think also bigger greenhouses, higher greenhouses with the pad above the crop, and then HAF fans to mix that air as it passes through the greenhouse, I think is another system, as opposed to having that column of cold air traveling across the crop.
Correct. You're going to want to have air circulation. I mean, that's number one. If you don't have air circulation, I've seen people turn their air circulation fans off at night, which is even worse of an idea since the plants are transpiring and you're actually having a higher humidity buildup, especially underneath a blackout curtain.
Do you know of any indoor cannabis growers who are certified organic?
That's something that's kind of getting more popular, but it's, in my opinion, not a full official certification, just because like OMRI certification for vegetable production is a federal process. And that is something that you can't actually do for cannabis at this point, since it's not technically federally legal. But there are quite a few different companies out there. I know the Cannabis Conservancy Group, like I mentioned earlier, that did all those studies. They do an organic certification. And to me, if you're getting an organic certification from somebody, you're doing it, one, for the clientele you're selling to. So to be able to say, hey, we did it, we got certified, and we're displaying this in our dispensary, now people will walk in and they might be coming just to you because they want organic product. So if you're an organic grower, which is great, and you're pushing forward with that, I definitely recommend looking at getting an organic certification.
Okay, interesting. Humidity. You talked a fair bit about that. Jeff, hey Jeff, wants to know about if you could use a desiccant system to reduce humidity, such as Anorama. I am unfamiliar with that.
I'm unfamiliar with the Anorama, but I know people are using I can't say it, but desiccant.
Desiccant. That's like those little packets of things you find in the top of a pill jar, right? Except a whole lot of them, I think.
But no, there are a lot of people utilizing those, and there are a few companies that are starting to do it. but I haven't seen like too many growers actually going that route.
Okay, well maybe it's a frontier there
Yeah.
to go into. Now, Jarius is asking, isn't the choice of indoor versus greenhouse moot in some states where only indoor facilities allowed? He mentions Illinois, but I know it's a fact that you can grow in greenhouses in Illinois, and I think
Correct.
most states that have implemented new laws recently are allowing greenhouse. But I have heard of counties in Colorado, I think Denver County, in fact, only allowed indoor growing, at least for a while. So are there places
That,
that only allow indoor?
That is correct. There are certain areas that only allow indoor production. And in my opinion, sure, you can wait and go for the greenhouse production when it comes available, but really you want to get your foot in the door. You want to develop those standard operating procedures, develop your nutrient recipes, your light recipes. You want to come up with all of this stuff now, and it looks good on you for when you want to build out and do a greenhouse. So if you are going indoor, again, there are benefits. You just need to make sure that you do it properly. Like again, I'm going to keep pushing that I feel that you should be using LED lights if you are an indoor grow.
All right, we've got a question about LEDs. Let's. Max wants
All
to
right.
know: are you convinced that LEDs are comparable to HPS in a greenhouse setting?
There's only a few fixtures out there. Great question, Max. There's only a few fixtures I know of that are out there, and I showed a couple of those in the slides before. And that's going to be the Fluence light, and also BIOS came out with their own greenhouse fixture. So I definitely recommend looking at that. But there are a few other LED companies that I've seen in greenhouses. Not sure on how the end product resulted in, but they are also a benefit for the fact that you can control it a little better now that you don't have tons of HPS lights coming on and creating this heat. Because every time you create heat, now you have to cool it. Another thing I've also seen from a lot from LEDs is the spectrum that they're providing is actually going to increase those reds and purples that are naturally in that strain. So sometimes you might have a strain that's really, really purple or red, and that chemical in there is actually called anthocyanin. And you can actually enhance that by using LEDs sometimes. So when you have a customer that's like, ooh, I really want the perps or the purple, that those LEDs are going to help those customers for the fact that you're going to have a really high anthocyanin plant, which is going to increase that color.
Right.
But yes, yeah, LEDs are coming around. I was not a believer for a long time, and I'm starting to see the technology there.
Yeah, he mentions that it seems counterintuitive to have lots of LEDs hanging above a crop, actually shading the crop from the sunlight that you want coming in. But really, the modern LEDs, the strip types, long and thin, that can go right underneath your
truss.
Truss or whatever.
Yep.
And the thing to remember with LEDs, I've done a lot of webinars on it, is you don't need a high output of visible spectrum. So you think that, well, if there's not many lights, there's not much light coming out, it must not be working. But as you said, it's the blue and the red that the plant sees, as opposed to the white light that, from all these parking lot lights that we've been using for generations to light our crops, because that's really what they are, So,
yeah, and I recommend some of those companies I mentioned. There are the long strips where they designed it for the fact that they want it to fit right underneath that truss bar that you have in the greenhouse, so that in fact there is no shading. Another benefit to LEDs is the fact that you can have a 0 to 10 volt connection, which means that you can dim or raise the intensity of that light so that you can have, an optimal, very nice square footage when it comes to micromole value on your canopy.
All right, we got time for just a couple more. Kayla wants to know, what do you think of the light cycle where you have about 12 hours on and then interrupt the dark cycle with 2 to 3 hours of light? It uses less energy, still keeps cannabis from flowering. But what is your opinion?
Yeah, that would be called night interruption.
Right, or mum lighting is the same kind of thing that,
Yeah.
7 minutes on and 23 minutes off kind of a thing for a chrysanthemum photo period.
Yeah, correct. And I've seen people actually also do it for certain trees and stuff for starting them in greenhouses. So it's one of those things that a lot of other crops have been utilizing, but I haven't seen one person utilizing it for cannabis yet. So I can't tell you if there's benefits to doing that or if there's negative outcomes from that. But it is something that I would love to see more research on. And it was a great question.
All right. Rob wants to know, how long does it take, because this is what you do, how long does it take to get a control system designed? And what's the process look like?
So what the process looks like for a control system, this is going to be whoever you're going with, is usually you need an overhead of where all your zones are, whether it's 10 greenhouses or 10 grow rooms or however, just an overview. Then we'll need to know what type of in power you have coming into the facility, so site power. And then we also need to know what equipment you have, the quantity per room, and the specs on that equipment. That sounds like a lot, but a lot of times these rooms and these greenhouses are pretty much identical in certain ways. There's just multiple of them. So usually if you can provide an equipment list for per each zone and what sensors you want, then you can go ahead and get an estimate from any of these control companies. When it comes to building your facility or your controller for your facility, they'll have to be building large contactor panels, which are basically have all the connection points for your equipment, your sensors, and how your sensors are being connected. And then that will actually connect to either a computer or a touch screen or some type of control module. And to get all of that done and sent out to you, it's going to depend on who you're going with. But I'd say on average in the industry, from what I've heard, it's typically anywhere from 8 weeks to 16 weeks. And I've seen even longer than that. And that's usually from the time that that company has all your information for equipment and your overhead.
All right. We've got quite a few more questions and more coming in, but we bumped up against the top of the hour, so we're going to have to hold it right there. But email your questions to Nick at nick.earls@wadsworthcontrols.com. I guarantee he will answer every single one of them. No problem. I actually have one last question because I am the host here. I can do it. You've grown, Nick, in both greenhouse and a warehouse type setting. What do you prefer? If you were going to do it professionally, commercially, what would you do?
Greenhouses, hands down.
Why is that?
Hands down. Well, mainly, again, with the price of the product dropping so much, you really need to think about how much utility consumption you're using, because you want to spend X amount of dollars to make X amount of product, and that's something that needs to be considered. The other things that you need to consider is the fact that you're getting a full spectrum light, the sun, and now you're only supplementing with these grow lights for whatever times you need it. To me, it's hands down greenhouses.
All right, there you go. Well, everybody, and we had some questions about, can I watch this again? Yes, the webinar will be archived as soon as it's over. Give me a little time to get it up at the same place you signed up, growertalks.com/webinars. And come on, slide, change. I know we have another one there, right? We do have another one. Thanking our sponsors, the National Greenhouse Manufacturers Association, Wadsworth, who supplied Nick, and Grower Talks, because I do this sort of thing. So that said, I want to thank you, Nick, for the webinar. It was great information. We should do this again and go more in depth, since we just kind of brushed across the surface of it. So on behalf of all the fine folks at NGMA, Wadsworth, and all my staff here at Ball Publishing, who work hard so I don't have to, I'm Chris Beatty saying so long, everybody.
Thanks.
Well, the band's in rare form today.